math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Hello, everybody. This is Mr. Witt with Fort Bend Tutoring, and today we have the High School Algebra 1 Final Exam Review. That's right. So that means that we will be going over what's going on. Soft Pro Fit Airman TV is in the house already. And Charmaine is in the house. How's it going, guys? Good to see you. And we will be going over this second semester final exam review for Algebra 1. Now, Algebra 1, guys, is a course that an 8th grader can be in, even a 7th grader, but most people take this course in 9th grade. What's going on, Tamaya? And of course, that means that there's a possibility that you could be in 10th grade taking this course. And of course, many college students take this as a developmental course in the form of intermediate algebra at a community college or junior college. If you have forgotten a lot of your mathematics, if you haven't taken a math class in a long time because you're going back to school at a later age. So this particular review will help many of you out there. So that's why I'm so excited about what I have compiled for you today and the problems that we'll be covering. So if you will be so kind as to subscribe to Fort Bend Tutoring. Also, guys, make sure that you are sharing the stream with everybody that you know and love. And of course, like the video, and let's just keep it moving today, guys. So everybody's in the chat. How's everybody doing? We're going to go ahead and get things crack-a-lacking today. Oh, yes, we will. We're going to get everything on and popping with Fort Bend Tutoring and Mr. Witt. There you go. All right, so let's go ahead and get things going, guys. We have problem number 1. It says, what is the product of the following expression? What is the product of the following expression? Here we have a monomial times a trinomial, meaning that we have 3 terms times 1 term. That's right. That 1 term, that monomial, is going to be multiplied times the 3 terms that you have within the parentheses. You should know that terms are separated by plus or minus signs. That's why I know that there are 3 terms within the parentheses, because this plus sign here is separating these 2 terms, whereas that minus sign is separating these 2 terms. If we were to name the terms within the parentheses, these terms would be x squared, x, and negative 5. That's right. That minus sign will count as a negative sign for that last term. Amen, amen. And of course, if you guys have been following me at any length, then you know I'm about to get my arrows popping. That's exactly what I'm going to do. Uh-oh, what's going on here? We don't want that. We don't want that. Had a technical difficulty here. Let's get back to what we need to be doing. All right, live streaming. All right, we were just trying to get this last arrow to pop, guys. That's what we're trying to do. So let's go ahead and multiply this out. We have 2x squared times x squared. That gives us 2x to the 4th power. We have 2x squared times x. That gives us 2x cubed. And then we're multiplying 2x squared times negative 5. That gives you negative 10x squared. And of course, after you distribute, you always look to see if you can combine like terms. And in this case, all of our terms are different because all of our variables are raised to a different exponent. Oh, yes. So that means that we will be red boxing our answer. There we go. That's what's up. The answer is 2x to the 4th power plus 2x cubed minus 10x squared. And there you have it. Ladies and gentlemen, we have problem number 1 in a can. Well, it's in a box. So let's go ahead and move on to our next problem. There we go. We have problem number 2. Problem number 2. It's on its way. There we go. Let's go ahead and get this in view. Let's get this in view. There we have number 2. We have a function that's given to us, and the name of the function is g. It says let g of x equal to 2500 times 8 to the x power, and to select all of the equations below which represent solutions of g of x. So what we'll do is we have 2 examples, okay, that will be using this function g, and we're going to be evaluating it. We're going to be finding out the values of these functions, of these values, once we plug them into the function here. All right, so what you see inside of the parentheses is the value of x that we'll be plugging in to our given function. So as to write this out, we can rewrite this as 2500ths times x is times 8, raised to the 0 power. Yeah, that's what we can do. What's going on there, Richard? Good job there. All right, so with this problem, guys, anything that we have, any base other than 0 raised to the 0 power is going to be equivalent to 1. So that means that I have 2500ths times 1, and this equals to 2500ths. Or you can write it as 1/4 if you want to be fancy and write it as a fraction. So the result here is 2500ths. Is that what you were saying there, Richard? That you had 2500ths as the result there? Okay, because that is correct. And let's go ahead and see what happens when we plug in 2 into our function here. Let's see what happens with that one. Plugging in 2 into the given function, we'll have the 2500ths times 8 raised to the 2nd power. All right. Well, as I showed you earlier, guys, that means that the 2500ths is 1/4. Okay, I'm going to use that if I can draw a 4. Can I draw a 4 today? There we go. And I know that 8 squared is 64. So basically we're taking a 1/4 of 64, which is 16, and then we will red box it. Amen. Amen. Richard says, I'm taking calculus in college right now. You have helped me a lot. I love your videos. Thank you so much, Richard. I appreciate your support and your patronage. There you have it, guys. That's problem number 2. And yes, just to let you guys know, Richard is in the house. There you go. There's Richard right there with his chat and his correct answers. He's nonstop. He's on fire already, guys, as we are moving through this Algebra 1 final exam review. Amen. Amen. All right. With problem number 3, guys, it says to write the function y minus 3 equals 2/3 times the quantity of x minus 4 in the equivalent form most appropriate for identifying. All right, for identifying the slope and y-intercept of the function. All right, so that's supposed to be most appropriate. Let's change that up because that is incorrect. Okay, let's hook this up. There we go. All right, hopefully I spelled that right. Okay, that would be nice if I could spell that right. There we go. So we want to take this equation, this linear equation that's currently written in point slope form, and write it into slope intercept form. Remember, slope intercept form is y equals mx plus b. See, this is the form that would be most appropriate for identifying the slope and the y-intercept. So let's see how we'll go ahead and convert that into slope intercept form. So starting out with our given equation, this y minus 3 equals to 2/3 times the quantity of x minus 4. Well, what we can do is we could go ahead and just distribute the 2/3 off the bat. You could do that. Or you can multiply everything by 3 if you want to get rid of that fraction. So what am I going to be leaning more towards right now? I think I'm just going to go ahead and distribute. So I'm going to get my arrows popping here. And we'll have y minus 3 equals to 2/3 x minus 8/3. All right, so let's fix that 8. We can do a better 8. There we go. So multiplying 2/3 times -4 will give you -8/3. Amen, amen. From here, guys, we'll go ahead and just add 3 to both sides of the equal sign in order to isolate our variable y. All right, so that's what we want to do here. If I can get a good line going. There we go. So your 3's will cancel out. What's going on, Arian? Good stuff. You caught the live session, Arian. Thank you so much for chiming in today. And then bringing down the y, which equals to 2/3. Our x here, we have minus 8/3 plus 3. But that 3 is over 1. So I definitely want to rewrite this so that we can combine the -8/3 and the 3/3. So with a common denominator of 3, we could say that this is 2/3 x minus 8/3, and then say that this is plus 9/3, okay? And then this will allow me to go ahead and combine those like terms at the end. What's going on, Jordan? How you doing? Good to see you. So now we're going to go ahead and simplify this into the form y equals 2/3 x plus 1/3. Oh, yeah. And now I can red box this answer right here, guys. And that is the answer. Done and done. I appreciate that, Jordan, coming back with that mister in front of that wit. Appreciate that, sir. Good stuff. Let's go ahead and give the chat some love again. There we go. As we move on to our next problem in the Algebra 1 final exam review. There we go. All right, so here it is, guys. Our next problem. It's a linear problem, and they clearly want me to get my arrows popping. So that's exactly what I'll do. So in number 4, it says to solve the equation. Well, this linear equation, there you go. We're going to go about doing that. Jordan says, how about some point slope form? Well, sir, we had points. They gave us point slope form in the previous problem. Okay, so I don't know if you missed that part, but we were asked to write that previous problem in slope intercept form. So we may get back to some more point slope. Richard says, do you have any calculus videos? Of course I do, Richard. Look under the playlist for Fort Bend Tutoring on our main channel, and there's a playlist called Calculus. There are a few videos there. We are mostly heavily algebra weighted right now, but we do have a few calculus videos. All right, so let's go ahead and solve this linear equation for problem number 4, guys. We will be definitely getting our arrows popping, just like so. And so now, in distributing, my favorite property, by the way, we'll have the negative 4 times x. That gives me negative 4x. Oh, yes, it does. The negative 4 times 10 gives me negative 40. I'll bring down the negative 6. This equals to negative 3 times x, which is going to give me negative 3x. And then finally, the negative 3 times negative 2 gives me positive 6. That's right. Richard says algebra is key in calculus. Absolutely. In fact, Richard, it's the hardest part of calculus, is finding out that you have weaknesses in your algebra foundation. So this is a great place to strengthen that. We'll be combining our like terms on the left side of the equal sign. We'll be bringing down the negative 4x minus 46. This equals negative 3x plus 6. And then we're going to isolate the terms with the variable x. That's right. And I believe I'm going to choose to put them on the right side. I like a positive coefficient, guys. Just a personal preference. I know that many students always solve for the variable on the left-hand side. I don't. I generally will try to go to where my coefficient on the variable x is going to be positive. So I'm over here on the right side with my variable x here. And I have negative 46 equals to x plus 6. Then I'll be subtracting 6 to both sides because I'm not scared of this problem. Not anymore. We have negative 46 minus 6. That gives me negative 52, guys. And negative 52 equals to x. And you better believe I'm put a red box around this answer. I have to protect my answers in a red box. Well, actually, it's protecting the public so that they won't get out, and do crazy stuff. Because, my answers are wild with it. Okay, so I put them in a red box to protect the answers. That's problem number 4, guys. That was solving a linear equation, and you could also call it a multi-step linear equation. Yeah, we did that. We're so moving on. We are so moving on now. Okay, with problem number 5. What's going on? Think 2. Good to see you. Good to see you today. Think 2. We have problem number 5 where they said to give the domain and range of the relation and tell whether the relation is a function or not and why. All right, this problem sounds like it's kind of being a little greedy on what they want us to do, but we're going to go ahead and answer these questions. Here's what we got. So just recall, guys, that a relation is a group of ordered pairs. A relation is a group of ordered pairs, and that's what we have. We have 1, 2, 3, 4 ordered pairs. Note that all the values within those ordered pairs are normally labeled as the x and the y value for each term. And as far as the domain is concerned, they only want you to give them the different values of x. In other words, the question is asking, what can x be? That's all they want to know. So as far as the domain is concerned, we'll go ahead and open up a set here, okay, because I can't draw a good brace, guys, so that's about as best as it's gonna get. So I have my brace waiting on me as I list the values of x that I have in this relation. So I have negative 8, I also have negative 5, I have 7, and I have 8. And this is the domain for this relation that we're given. Yeah, they just want to know the x values. You don't like that 5? I don't like that 5 either. That's a better 5 now. I hooked up that 5. There you go. And now moving on to the range. The range is asking a similar question, but of course it's just asking about the y values. What's going on, Fabiola? Glad you could join us. So here, the range simply wants to know the y values. That's all they want to know. They just want to know what y can be. So tell them. Go ahead and tell them what y could be. Oh, that's an ugly brace. Why can't I draw a good brace? We're gonna keep this brace. Thank you. So the y values that we can have are 1, 3, and -6. And I want to go in ascending order. So I'm gonna go with -6, 1, and 3. And notice that I didn't write the 1 twice. So even though what is up with this brace, guys? Oh my God. Okay, thank you. I think I just need to cut off someone's hand that can draw a good brace and just sew it on mine, because this is not working out with me at all, the braces. Guys, the y values for this relation are -6, 1, and 3. So there it is. That's all you need to write. Even though we had 1 repeated as a y value, it doesn't matter. It doesn't matter at all. You just write it one time. Don't write it more than one time. I will find you. Don't do it. It's unnecessary. Okay? So Arian says, best math tutoring channel I've found so far. Thanks, Mr. Wood. It's all good, Arian. There you go. Gonna have to upload a brace drawing video. Man, it's not gonna save me, Arian. I'm not gonna be able to draw. I'm not gonna be able to draw a good brace. Thing 2 is probably confusing because I was hovering over my failure at drawing a brace. Here's what you need to know about this thing 2. When they ask you about the domain, you need to know that every ordered pair is broken down into x values and y values. Okay? X values and y values. And because they are asking you for the domain only wants to know the x values. Notice that our x values in the relation here are -8, -5, 7, and 8. That's why our domain is also -8, -5, 7, and 8. When it comes to the y values, they're asking about the range. That's the relationship between those that name is that when they refer to the range, they're referring to the y values. So they only wanted to know that the y values can be 1, 3, and -6. And because we're putting it into a set, we usually write it in ascending order. So that's why I'm going with -6 first, telling you that you can have 1 as a y value and telling you that you can have 3 as a y value. All right. So that's what they want to know from there. Now, as far as telling the reader, or telling the question, or answering the question, is this relation a function? As far as this being a function, the answer to that is yes. It is a function. And the reason why it's a function is because your x values do not repeat. So anytime your x values will repeat, that's when you do not have a function. But because our x values don't repeat, all of our x values are unique. They're all different. That's when we end up saying that we have a function, that this relation is also a function. And of course, we're going to red box it. All right. Well, Think 2 says that he understands it now. So that's good. And maybe some of you will understand it better, that I went ahead and recapped over that and gave you a different way to view it. You know what I'm saying? So that's problem number 5. And it's done, son. Let's move on to problem number 6. Here we have problem number 6, guys. They ask us to divide a polynomial by another one. And more specifically, we have a trinomial divided by a monomial. That's exactly what we have. And I'm going to show you guys a couple of ways to attack this problem. That's right. So Richard Haynes says that we could use synthetic division. I wouldn't do it on this problem, Richard, okay, because of the drama that synthetic division can give you when it's not in a specific format. So no, I'm actually going to show you guys a couple of ways to do problem number 6. The first way is going to be as follows. Please note that a fraction is a division problem, guys. So what you could do is you could start off by rewriting this problem as 16x to the 6th power minus 12x to the 4th power plus 4x squared all over 4x squared. So what did I do at first? I just rewrote our problem as a ratio. That's exactly right. Richard, having missing terms is not why we are going to avoid the synthetic division. All right. But you can check out my synthetic division video that I have, and it will show you clearly what I prefer, the type of problems that I would prefer to use synthetic division on. All right. So yeah, so this is definitely not the form that I would want to use synthetic division on, but it's not because there's missing terms, but that is a good way to look at the problem. So check this out, guys. The method that I'm going to solve for this one, though, is first of all rewriting the problem as a fraction, as a ratio, and then expanding the problem. Okay, so Richard is saying that we could factor out a 4. Okay, you could even go ahead and say, Richard, that you could factor out 4x squared. You could do that, but I'm not going to even do that. Oh no, I'm going to do something else. I'm going to go ahead and expand this problem and write each term over the common denominator of 4x squared. So as I promised you, I will show you multiple ways to solve this problem here. But the first way I wanted to show you is to simply rewrite the problem as a ratio and then expand it by placing each term over the common denominator of 4x squared. Once we have this, now simplify it. Okay, so simplify each term now. That means that 4 goes into 16 4 times, and because we're dividing like bases, you're going to subtract the exponents. So our first term becomes 4x to the 4th power because we subtracted 6 minus 2 in order to get x to the 4th power. Then for our next term, we know that 4 will go into 12 3 times. So this gives me a negative 3x squared because we subtracted the 2 from the 4 as far as those like bases of x are concerned. And then finally, guys, we have 4x squared divided by 4x squared. Well, that's just going to be 1. Yeah, anything over itself is 1 as long as x does not equal to 0. So therefore, we have our result here. That is right. We have our answer of 4x to the 4th power minus 3x squared plus 1. That's exactly what we have done as far as problem number 6 is concerned. Oh, yeah. So that was one of the methods that I wanted to show you guys. Just one of the methods. Let's keep it moving, okay? On to a reminder. That's right. To subscribe to Venn Tutoring, you can find a subscription link in the description box below, guys. Also, remember to share the stream with the people that you know and love. And, of course, like the video. That's right. And if you want to go ahead and be notified when we're doing live streams, as we are right now, or anytime we're uploading new content, go ahead and click on that bell icon. That helps you get notified when we are. That's right. Think 2 says subscribe, people. That's when we are going to be live with our new content, and we appreciate every subscription. Thank you so much. We try to provide a good service for you guys. Let's keep it moving now. All right, on to a different way to solve problem number 6. That's right. I was prepared, guys. So the first method, we went ahead and rewrote the problem as a ratio, and then we expanded and simplified. That's right. Richard Haynes says that I'm the Morgan Freeman of math. I appreciate that compliment, Richard. He has a lovely voice. So what we're going to be doing in this case, all right, is, let's see here. Man, I think, do I want to, yeah. You know what, guys? I think I'm going to go ahead and do long division on this. Yeah, I'm going to do long division on this. That'll be the other way I'm going to show you. All right. So as Richard pointed out, you could use factorization to assist you in the simplification process. But I think I'm going to show you guys long division. That's what I'm going to do. So I'm going to rewrite the problem as 16x to the 6th power minus 12x to the 4th power plus 4x squared. And actually, you could go ahead and show your missing terms, Richard, in this problem, but I don't think it'll be necessary. All right, so let's find out why. So first of all, we're going to just focus initially on our divisor, okay, the 4x squared. And we want to know what we can multiply 4x squared by in order to end up with 16x to the 6th power. Well, we know that 4 goes into 16 4 times, right? And if I only have 2 x's in my divisor, and I want to end up with x to the 6th power, I'll need 4 more x's. So I need to multiply by 4x to the 4th power. Okay, and then we, of course, multiply this out. So 4x to the 4th power times 4x squared will give you your 16x to the 6th power, like so. And then, of course, you need to change the signs. And when you do that, that cancels out, and we'll bring down our next term, which is negative 12x to the 4th power. From here, we'll go ahead and realize that we need to multiply 4x squared by negative 3x squared in order to end up with negative 12x to the 4th power. So you're always looking at that first term in your divisor and trying to see what you need to multiply it by to end up with the term that you're looking at in your division process here. Okay, so knowing that 4x squared times negative 3x squared will give me negative 12x to the 4th power, we'll go ahead and multiply that out now. So negative 3x squared times 4x squared gives you negative 12x to the fourth power. And then after this step, we need to change the signs. That's right. And here they become additive inverses. They cancel out, and we'll bring down our next term, which is 4x squared. So what do we need to multiply 4x squared by in order to get 4x squared? Well, we need to multiply by 1. You know what I'm saying? So there you have it, as this 1 times 4x squared gives us 4x squared, and then changing the sign will terminate and we'll end up with 0. That just lets you know that you're done. That just lets you know that you are done. We're going to red box it. And done, ladies and gentlemen. That is problem number 6. Constant Gaming says, great tutorial, brother. Love this channel. I appreciate you, Constant Gaming Squad. I love you, bro. This channel loves you. How about that? One of the benefits of the live stream, guys, get that direct contact. That's right. We get to communicate live with problem number 7. Okay. And in problem number 7, they want us to solve this proportion. That's right. Anytime you have a fraction set equal to another fraction, you have a proportion. And there are a few ways to solve even a problem like this. And you know what? I got to give it to you. I'm going to go ahead and show you 2 different ways to solve this problem, guys. That's what I'm going to do. I didn't even plan on it. But since you guys are being so good to me today, I got to be good to you. I got to be good to you. Okay? All right, so here we go. I'm going to go ahead and show you 2 different ways to solve this problem as well. All right? So, Richard says, am I a college professor? The answer to that, Richard, is yes. Absolutely, I am a college professor, sir. Thank you for asking. All right. We have problem number 7, guys. We have 4 over s. That's right. That this symbol that looks like a 5 is an s. Thank you. You know what? I don't even know why they even give us problems like this, guys, because it irritates me. Why give me a symbol that looks like another math symbol? Let's go with x, guys. We're going to go ahead and change up this problem, make it better. There you go. So we're going to rewrite this as 4 over x equals to negative 2 ninths. That's exactly what we're going to do. And you know what? If I'm going to do this for real, I need to go ahead and make sure it's in the same ink. All right. So it needs to be in blue because I'm going to solve the problem in black. That's right. We don't want to confuse anybody. There we go. So the first way I'm going to show you guys is that once you have a fraction set equal to another fraction, you can use what is called the extremes means method, aka you can cross multiply. Let's go ahead and get these arrows popping, guys. So we know that 9 times 4 is 36. We have x times negative 2 is negative 2x. And of course, we're going to use the division principle of equality and divide both sides by negative 2 so that you have x equals to negative 18. Is your answer in a red box? Because mine is. Oh, it's in a red box. You're going to get your box on. That's what you're going to do. Here's the other way to solve this problem. Let me show you that. The other way to solve this problem, guys, is to realize that they multiplied negative 2 in the numerator. They multiplied that value by negative 2 in order to get a positive 4. Remember, the left side is equal to the right side, right? So in order to create an equivalent fraction on the right side, if they multiply the numerator by negative 2, that means I need to also multiply the denominator by negative 2. And when I do that, see, multiplying straight across, negative 2 times negative 2 is positive 4, right? Well, that means that x has to be equivalent to 9 times negative 2, which is negative 18. It's over again. It is over once again. There you go. There you go. 2 ways to solve that problem. Thank you. I appreciate that. I'll be here all week. Just, hanging out in the lobby. Appreciate that. We have problem number 8 now. Thanks. Problem number 8 is now in effect. With problem number 8, we have to graph the inequality y is greater than negative 1/2 x plus 2. Now, you should be able to recognize that they already have this problem written in slope-intercept form. But see, that's going to be a big help to us because that means we can quickly identify that the slope of this inequality is negative 1/2 and the y-intercept is 2. And I will definitely start graphing this at 2 on the y-axis. Okay, so just keep in mind that that b value is the y-intercept. In other words, it's where the line touches the y-axis. That's what's up. That's exactly what's up. Let's go ahead and use I think we'll use some purple here. Thank you. And I'm going to start at 2 on the y-axis. So I'm going to put a point at 2 on the y-axis. That's my first point. Thank you. Then using the slope, I can go down 1 and to the right 2. Or I could have gone up 1 and to the left 2. Same line. Yeah, same line. Thank you. Appreciate that. From here, you should realize that anytime you have a greater than symbol, guys, if it's a less than symbol or a greater than symbol, you're going to use a dashed line to represent it. If you had a less than or equal to symbol or a greater than or equal to symbol, you better use a solid line to represent that on your Cartesian plane. So since this inequality has a greater than symbol, I'll be representing my line with a dashed line. Oh, yes, I will. So let's go ahead and hook up that dashed line here. All right. So is it going to work for me today? Am I going to? Okay. Close enough. Close enough. Thank you. Thank you. That's my dashed line. Okay. Yes, I know yours looks better, but that's okay. That's all right. I'm doing this on the fly. There we go. See? Better dashes or maybe not. No. There. Yeah, it's going to be okay. There we go. We have a dashed line now. However, you need to also shade in the region where your solutions lie. Arian says the sign on the slope only affects the y. Not necessarily, Arian. I'm glad you asked that question. Let me go ahead and explain something to you. When it comes to your slope of -1/2, right now it starts out with the negative being in front of the fraction, right? So it's the opposite of 1/2. But you can also write this two different ways. You can write it as -1 divided by 2, where the negative would only affect the y value, or you can write the negative in the denominator, and then it would only affect the x value. So it depends, because we do know, if you're familiar with the slope, that you're dealing with the rise divided by the run, or you could even say that this is the change in y, delta y, divided by delta x, as far as the slope is concerned. So that means that it depends on how you're writing the slope as far as which values the negative will affect. Okay, so if you choose to put the negative in the numerator, then yes, it will only affect the y. But you can also choose to put the negative in the denominator, and then it would only affect the x values. That choice is yours. I showed you the results of doing both. I started at the y-axis, okay, that y-intercept of 2, and I went down 1 and then to the right 2. That shows that that negative sign affected the y value. But I also went back to that y-intercept and went up 1 and then to the left 2. That version shows you that the negative sign affected the x values. So I gave you both. All right. So good question, Arian. Thank you for asking that. So the next thing I'd like to do, guys, is to show you how to shade the inequality. And what I prefer to do is I prefer to use a test point. That's what I prefer to do. And the test point I usually will choose is the origin, especially if the line doesn't go through the origin. And in this case, it doesn't. So if I plug in 0 in for x and 0 in for y, this inequality would read is 0 greater than 2. That's what this inequality would read. Now, is that a true statement or a false statement? That's the question you should ask. And the answer to that is it's a false statement. 0 is not greater than 2. So that means that we should shade on the other side of the line. So you could use your generic shading rules. For instance, if it's greater than or equal to, that you should shade above it or to the right of the line. And if it's less than or equal to, you should shade down or to the left of the line. But that confuses me sometimes. So I like to use a test point to verify which part of the graph I should shade. And so if this open circle here is that's just showing you that I use the origin as a test point, you can just erase that. And this is the graph. There you go. That is the graph of the inequality for problem number 8, guys. Done and done. Oh, yes. And now we're moving on. We are moving on to our next problem, which is problem number 9. And in problem number 9, they want us to solve the inequality m-8 is less than or equal to 14. And we'll go ahead and not only solve this, we're going to also show this result on a number line. That's what we'll do for problem number 9, guys. So in order to solve for this inequality, all you have to do is add 8 to both sides of the inequality symbol. That's it. So you'll have m is less than or equal to 22. Okay, so this is the result. This is the solution of the inequality. So if all they want is the solution of this, then the answer is m is less than or equal to 22. However, if they wanted to see this on a number line, okay, so on a number line, the most important value on this number line would be 22, of course, because that's what we're referring to. And in Algebra 1, we're still using open and closed circles most likely. So you would use a closed circle because you're including the value of 22, and then you would shade to the left, okay? So that's what you would do for problem number 9. You would go ahead and show that it would be a closed circle for 22. That means we're including the value of 22, and that values that are less than 22 are found to the left of 22. Yeah, that's it. I mean, that's all there is. I guess the only other option that you may see in Algebra 1 is set builder notation. Let me go ahead and show you that. That you could have it written as m is such that m is less than or equal to 22. So this is another way that you may see it in your Algebra 1 class. All right. So there you go. Those are 3 different ways that you can solve that inequality and represent your results. There you go. Yeah. Yeah, that's problem number 9. I'm happy with that. There you go. We're on to problem number 10, as we are simplifying the expression a cubed b all raised to the 4th power. That's what we're doing. And so you should know, guys, that anytime you have a monomial, meaning one term inside of a set of parentheses, and you have it raised to a power, that you will multiply all the exponents within. And what you should be able to recognize at the start is what your actual exponents are, guys. So you should know that you have a to the 3rd power. You should also know that b is to the 1st power, and that all the exponents within those parentheses there, you are going to multiply every last one of them by 4. So we end up with the following result. You'll have a to the 12th power because I multiplied 3 times 4 to get 12. And you'll end up with b to the 4th power because I multiplied 1 times 4 to get 4. And that's it. It's over. Yeah, I'm putting a red box around my answer. That's it. That was problem number 10. Done and done, guys. So anytime you just have one term inside of a set of parentheses, all you need to do in order to solve it is multiply all the exponents within by the exponent that's on the outside of the parentheses. Richard is correct. A to the 12th power times b to the 4th power. The only thing I would have you watch out for, Richard, is make sure that your variables are lowercase, because that makes a difference, sir. All right? That there's a difference between a capital A and a lowercase a. You want to keep the same notation that you find in the original problem. Amen, amen. All right, that's problem number 10, guys. Done and done. And we're moving on to problem number 11. That's right. Here in problem number 11, we have a literal equation. We have a formula. And they're asking us to solve the equation for d. So we won't end up with an exact value here. We won't actually know what the answer is necessarily, but they do want us to isolate the variable d, get it by itself. We want to solve for a positive 1d to the 1st power. That's what they're wanting us to do. So that's what we'll give them. So let's first of all start by isolating the term. Okay, Richard says that he knew better. So we're going to isolate the term with the variable first that we want to solve for, which is the variable d. So that means that the term 3d is what I want to get by itself, guys. So we'll start by just subtracting ef to both sides of the equal sign. That's what I'm going to do. That's what I'm going to do. And you'll end up with 6e minus ef equals 3d, as these additive inverses will cancel out on the right side of the equal sign. Oh, yeah. And then from here, you'll just simply divide both sides by 3. That's it. It's over. So you can say that this is going to be d equals 6e minus e to the f divided by 3. I am going to red box this, guys, because that's the answer. They wanted us to isolate the variable d. We did. We came, we saw, we conquered, and we red boxed it. That's exactly what we did in that order. That was problem number 11, guys. And now we have problem number 12. They want us to graph the solution of the compound inequality. Oh, yeah. A compound inequality. So we have currently negative 3 is less than or equal to negative 2x plus 1, which is less than 11. And what we will do with this, guys, is we're going to solve for the variable in the middle And whatever changes we do to the middle part of the compound inequality, we must also do to the left and the right side of the compound inequality. So what's good for the middle has to be good for the left and the right side of the inequality as well. So I want to start by isolating the term with a variable, getting that term negative 2x by itself. And I can do that by adding the additive inverse of 1 to each part of the compound inequality. In other words, I'm just subtracting everything by 1, guys. Subtract everything by 1. You'll end up with negative 4 is less than or equal to negative 2x, which is less than 10. Amen, amen. Then we'll be dividing each and every section, each and every part of this compound inequality by the coefficient negative 2. And remember that anytime you multiply an inequality or divide an inequality by a negative number, so let me restate that. Anytime you multiply an inequality or divide an inequality by a negative value, you have to change the sign of the inequality symbols, guys. So we end up with 2 is now greater than or equal to x, which is greater than negative 5. That's what we have. Let me fix that negative there. Better. There we have it. And since they wanted us to graph this result, because this is our solution, by the way, they wanted us to graph this result. Let's go ahead and see what this looks like on the number line here. Okay, so let's go ahead and hook that up. So what we'll end up with now is us recognizing that we'll need to put two values on here. Of course, the negative 5 and the 2. Starting from the middle and reading to the right, this says that x is greater than negative 5. So we'll need to have an open circle at negative 5, and we need to start shading towards the 2. Okay, but this also says, starting in the middle and reading to the left, this also says that x must be less than or equal to 2. That's exactly what it says. So if you were starting out, if you wanted to rewrite this, in other words, you could say that this means x is greater than negative 5, and, all right, let's get a nice little and working for us, guys, because that one was ugly, and x is less than or equal to 2. Yeah, that's what that means. So that means at the 2, you'll have another open circle, and it's going to be trapped in between. Yeah, that is the answer to this compound inequality. Done and done. So the type of compound inequality that you were dealing with, because of this and situation here, you were dealing with an intersection. This was an intersection. All right, because of the and there. And then that completes this. We have it all nicely graphed with open circles. Matter of fact, hold on, guys. I made a mistake. Because this is x is less than or equal to 2, we need to have a closed circle here at 2. Sorry about that, guys. Got carried away. There you go. Fabiola, you are correct. All right. Good job, lady, for catching that. The less than or equal to needs to be a closed circle, guys. The greater than symbol is an open circle. So sorry about that. I made a mistake, but we fixed it. No problems, no issues. If it's a less than or greater than, use an open circle on the number line. If it's less than or equal to or greater than or equal to, you use a closed circle to represent it. All right, so just got caught up there for a second, guys, but here we are. We're not leaving you with an incorrect answer. We went ahead and hooked that up for you, and Fabiola was on point with the correction. So just to remind you guys again to subscribe to Fort Bend Tutoring. You can find the link in the description box. Also, guys, please share the stream with people that you know and love. And in addition, if you're able to donate, please donate, as that helps us bring you more free content from me, Mr. Witt, and Fort Bend Tutoring. Let's keep it moving, guys, with problem number 13. Problem number 13, it says, which is the simplified form of this expression? Oh, yes. Which is the simplified form of this expression? Let's go ahead and start by realizing that we will need to follow the order of operations here. So you have currently 4 terms in this expression. The first term is the quantity of 2x plus 3 times the quantity of x minus 6. The second term is negative 2x squared. The third term is 3x. The fourth term is 30. And we're going to multiply these binomials first. That's exactly what we're going to do. Kaylee says that, hey, just wanted to let you know that I took the ASVAB yesterday and finally passed. I used to suck at math, which caused me to fail the pretest once last month. And now she says, but thanks to FBT, the math section was painless and I scored a 71. God bless you, Mr. Witt. I am so happy. Thank you so much for informing me, Kaylee. I'm so proud of you. You have been a loyal person to Fort Bend Tutoring. We appreciate you watching our videos, and we're so happy. I'm so happy that the videos helped you pass your ASVAB. Congratulations, and thank you in advance for your service to my country. There you go. There you go. Thanks a lot, Kaylee. You are awesome. You are wonderful. Let's go ahead and get these arrows popping, guys. That's right, because we can just bask in the glory of Kaylee all day long. All right, but we do have some math to do. So Fabiola says, congratulations, Kaylee. There you go. There's somebody got your back, Kaylee. Fabiola in the house. We have 2x times x, guys. X is going to give us 2x squared. We also have 2x times negative 6. This gives us negative 12x. We then will multiply 3 times x to give us a positive 3x. Multiplying 3 times negative 6 gives you negative 18. I hate that 8. We're going to fix it. Thank you. I'm going to keep that 8. I'm going to keep that 8 right there. So that's negative 18. Then we'll bring down the remaining terms, that negative 2x squared plus 3x plus 30. And there we have it. That's right. The good old foil. That's right. That's what Richard says. But I just like to get my arrows popping, Richard, with the distributive property. I don't have to remember what that FOIL stands for. All right, just get those arrows popping. From here, after you distribute, guys, you're going to always combine your like terms, and we're going to be writing our answer in descending order of x. Good old Kaylee holding it down with the passing ASVAB test. So proud of you, Kaylee. Thank you for sharing that information. We have 2x squared minus the 2x squared, guys. These terms here, these like terms, they're going to just cancel each other out. Yeah, because 2 minus 2 is 0. It's done now. It's gone. Whereas the x to the first power terms, when we combine those, let's see what happens. We'll have negative 12 plus 3, which gives us negative 9. Then negative 9 plus another 3 will give you negative 6x. So that's what we end up with that. Then combining the negative 18 and the positive 30. 30 minus 18 is 12, guys. And here is the simplified form of the expression. We end up with negative 6x plus 12. Done and done. Oh, yeah. That is it. We're going to go ahead and red box it. That's right. Problem number 13 in a red box. Let's go ahead and move along, guys. Let's go ahead and move along to our next problem, which is problem number 14. Oh, yes, it is. So with problem number 14, it says the ages of 3 friends are consecutively 1 year apart. Together, their ages total 48 years. What are the ages of the friends? Don't ask me why we care about these friends, guys, because clearly they're not our friends. But the ages of these 3 friends are consecutively 1 year apart. And together, their ages total 48 years. So what we're going to do first is we're going to define the friends, okay? So we'll define the first friend as lame, the second friend as lamer, and then the third friend as the lamest. No, I'm sorry. We'll say the first friend will be X. The second friend will be X plus 1. And the third friend is going to be 1 more than the previous one. So he'll be, or she will be, X plus 2. There you go. So we first of all realized that we didn't know the age of the first friend, the smallest friend in age, but we did know that the next friend would be 1 year more than the previous friend. That's right. And then the third one, of course, would be 2 years older than the smallest age friend. That's right. So Tony and Noah says Noah wants you to solve x over x minus 2 plus 3 equals a 2 over x minus 2. Does he, Tony? Does he? Well, we'll see what I can do if I can squeeze that in after I finish the problems that I have today, sir. Okay. Sir Penguin says, actually made it to a live stream. Congratulations, Sir Penguin. In the house with Fort Bend Tutoring. Let's go ahead and write, guys, this equation that will solve the problem that we have right here. So we're going to go with x plus the quantity x plus 1. Let's go ahead and fix my camera here. There we go. I think it's better now. There it is. And then this is going to be plus the quantity x plus 2. This has to equal to the 48 years. There we go. There we go. That's what's up. So we took the ages of the three friends, and we knew that the total of their ages had to be 48. So this is going to be the equation that we can use to solve for the ages of all three friends. Let's go ahead and solve for x, guys. So, hey, you used the A, Mr. Witt. Let's go ahead and fix that, guys. We want to use the same variable that we used there. Let's go ahead and fix that. We used an X. That's exactly what we used. See, I would try to be clever. Tried to be clever and messed up. So let's go ahead and combine our like terms here. We have x plus x, guys. That's going to be 3x. Just combining our like terms together. We can also combine the 1 plus the 2. That gives you 3. This equals to 48. Let's continue to solve this by subtracting 3 to both sides of the equal sign. From here, we have 3x equals 45, and then using the division principle of equality, you'll end up with x equals 15. Oh, yes, you will. So the age of the first friend is 15 years old. Yeah, that's appropriate for 9th grade. Then the next friend, 16. That's what's up. Then the next friend is 17 years old. So we have a freshman, a sophomore, and a junior, all friends together. There it is. Good job, Fabiola. Fabiola has our correct answers, knowing that the first one is 15, the second one is 16, and the third one is 17. Very good, because if we were to add all three friends' ages together, you would end up with 48 as a result. Done and done. What's going on, Mahler BT? Mahler BT, how you doing? Thank you for joining us today, Mahler. There you go. Let's go ahead and red box this. So we have solution 15, 16, 17. There we go. We're going to red box this here. Go ahead and put a nice little red box around that now. That's what's going on. All right, so there you go, guys, with the result. Done and done for problem number 14. Let's move on to the next problem. Problem number 15 is in the house. Let's go ahead and put Mahler BT back on the screen here so everybody can see her. Or him. We have simplify the expression square root of 48 divided by 147. That's what we have. That's exactly what we have. And so, in simplifying this, thank you, you will do the following, guys. Let's first of all realize that both the 48 and the 147 can be reduced by 3. Now, how did I know that? I use my divisibility rules. Okay, and the divisibility rules say that if you can add the digits together and the sum is a multiple of 3, then that means that it can be divided by 3. What's going on, William, in the house? So therefore, reducing 48 by 3 will give you a result of 16. Reducing 147 by 3, let's see what happens with this number here. I mean, it's ugly, clearly an ugly answer, but we know it can be divided by 3. So that goes in there 4 times. That's a 12. We end up bringing it down to 27. That is going to be 49 times, guys. 49 times. So you end up with 16 49s. But we're not done. Oh, no, we're not. That's right. Using that divisibility test. Mahler says, studying for my college algebra exams and your videos helped a lot. But when it came to the difference quotient, I can't find any videos on that. Unfortunately, Mahler, I don't have any videos that include the difference quotient as of yet. Sorry about that, Mahler. So what you could do is you could check out Patrick JMT. There is a link on our homepage that you can check out those recommended channels for a video on the difference quotient. Yeah, I need to make one, Mahler B. But it's only so many hours in the day. Sorry about that. So, yeah, so you can check that out for that one, and there you go. Now, as far as completely simplifying our expression right here, what we can do is we can go ahead and separate the radical, being as though 16 and 49 don't have anything in common anymore, any more common factors to reduce by. We can say that this is going to be the result of the square root of 16 divided by the square root of 49. And when you have a square root sign, guys, they're looking for the positive result. All right, so therefore the square root of 16 is 4 divided by the square root of 49, which is 7, and we will red box this answer. Fabiola had the correct answer. Richard has the correct answer. So Marla says, can you do some difference quotient in the future? Absolutely. Exam tomorrow, and you have the best videos. Had to look elsewhere. Sorry about that, Marla, but you know I don't want you looking at anybody else. I don't want you looking at nobody else but me. You already know that. But Marla says, thank you so much for your work. Yeah, so eventually I will have more videos that'll help you in a better way, Marla. But I don't have. I try to weigh my videos out with quality more so than quantity. There's a lot of people that their strategy is quantity, so they churn out a whole lot of videos. But I'd rather give you quality versus quantity per video. Just saying. That's just my own personal preference. We have problem number 16, guys. It says a sales clerk earns a 3% commission on each sale. What is the commission earned on a sale of $4,450? Well, the biggest obstacle in this problem here is understanding what a commission is. There you go. Yeah. So the commission is just a percentage of the amount. Yeah. And as far as making that money, that means that whatever your percentage is, if you sell a certain amount, you'll get a percentage of the sales. And that's exactly what we'll be doing here. Matthew Forgot says, please, how do you subtract 2 to the 5/3 minus 2 to the 3/2, leaving it in exponential form? Interesting. Leaving the result in exponential form. Yeah, you need to get a common denominator first for those rational exponents, Matthew Forgot. That's what you need to do. Get a common denominator on the rational exponents, which will be 6, and then go from there. That should help you. Absolutely. Molar BT says, been recommending you to all my classmates. Thank you so much. Got to get back to studying, so I'll catch you later. Take care, Molar BT. Appreciate you. All right. Let's solve this problem, guys. Matthew Forgot, if I have time at the end, I will hook you up. All right. But that is how you attack it. Okay. You get a common denominator for those rational exponents, and then you can go from there. All right. There you go. All right. So from here, guys, we are going to find out what 3% of this $4,450 is. That's what we're going to do. It's not that bad. Change the 3% into decimal notation. It'll be 300s. Okay. And then multiply this out. And then that'll be the answer. Okay. So 3 times 0 is 0. 3 times 5 is 15. Carry the 1. 3 times 4 is 12 plus the 1 gives you 13. Carry the 1. 3 times 4 is 12 plus 1 gives you 13. There you go. And so we need to move the decimal over 2 places to the left, right? We had 2 places behind the decimal there, guys. So we move the decimal 1, 2 places to the left. So for all those sales that the sales clerk made, that $4,450, because the commission rate was 3%, they earned $133.50. There you go. Way to go, sales clerk. Just earned yourself some money by making sales. Done and done. That's problem number 16. Yeah, that is problem number 16. And we're on to the next problem, guys. Problem number 17 with a Venn diagram. How you like that? That's right. So, Venn diagrams, guys, people that are watching this video, thank you, are great for organizing sets and visually having a representation of how sets are working together, how they overlap, how their intersections and unions can be visualized. That's what I meant to say in a cleaner way. So let's go ahead and read this problem out. It says that 30 people were asked if they wore a blue shirt or a red shirt this week. Currently, I'm wearing a blue shirt. Just letting you guys know. What is the missing value in the Venn diagram? That's what they want you to know. So we should have a total amount, all right, of 30 within this Venn diagram. So let's see how much we have right now. We know that we have 8 plus the 4 plus 11. Well, let's add that together then. So adding this together, we know that 8 plus 4 is 12. 12 plus 1 is 13. We'll go ahead and carry the 1. 1 plus 1 is 2. We'll get 23. So what's missing from the 30 people that were asked, 30 minus 23, guys, is 7. We're missing 7. So the missing amount is 7. There you go. It had to total, all of these values had to total the your universe, the amount of the universe, the total amount, the 30 people had to equal to that. There you go. We only had 23 showing. So you just add those up, subtract from your total. Good. That's right, Fabiola. Get that 7 in play. Fabiola had it, guys. She had that answer already. So we have problem number 17 completed, and we're moving on to problem 18. Done with that previous problem. So with problem 18, it says to write the linear equation 3x equals 12 minus 2y in standard form. Well, what is standard form of a linear equation, guys? Well, it's ax plus by equals c. And there's conditions for this. For one, the coefficients a, b, and c, they have to be integers. Okay, you can't have fractions or decimals. You need to know that. And also, the a value needs to be positive. So we're starting out with this 3x equals 12 minus 2y. And so in order to put this in standard form, you want to add 2y to both sides of the equal sign. You want to do that for sure. And then you'll end up with 3x plus 2y, and this equals 12. Yeah, it's over now. Yeah. So notice that all of our coefficients are integers, okay? And our leading coefficient, the a value, is positive. So that's it. Richard, you are correct, sir. There you go. Did you red box your answer, Richard? Because I'm red boxing mine, okay? Put it in the red box, Richard. It's not right, Richard, unless it's in a red box. You have to put your answer in a red box, okay? Or get away from you, okay? And come back to haunt your family. Put it in a red box. Protect yourself at all times. We have problem number 18 completed, guys. We are moving on to the fact that Richard says that this is all a refresher. Oh, I know it is, Richard. I appreciate it. I appreciate you hanging out with me for the refresher, sir. Go ahead and just a reminder, guys, to subscribe to the channel. There you go. Subscribe, share the stream with your people. You know what I'm saying? Go ahead and like the video. That's nice. There you go. Just a reminder. That's all. It's not going to hurt. Didn't hurt you one bit. We have problem number 19. Fabiola says, ha, protect your family. That's right, Fabiola. You have to protect your family. That's right. Put those answers in a red box. We have problem number 19 where we're going to simplify the following expression, guys. We have the quantity x squared y to the 6th power z to the 5th power times the quantity of x to the 4th power y to the 5th power z cubed. And we were going to, can I get my mouth to work right for a second? There we go. Sorry. We're going to multiply our like bases. And when we do that, you better believe we're going to add those exponents. That's right. We're going to do some multiplying and adding. That's what we're going to do. All right. Richard says, I'm on my phone laughing out loud. I can't red box it. I'm going to need you to red box there, Richard. You're going to have to get your life together, sir. Get it together, Richard. Okay. So here we have x squared times x to the 4th power. We end up with x to the 6th power. Multiplying y to the 6th power times y to the 5th power. Adding the exponents, you'll have y to the 11th power. Then finally, you have z to the 5th power times z to the 3rd power. You're adding the 5 and the 3 together to give you z to the 8th power. And you know I hated that 8, so I had to make a better one. And there we go. Thank you, Richard. Get your life right. Richard says that the answer is x to the 6th power, y to the 11th power, z to the 8th power with a red box. Very good, Richard. I will accept your written statement of a red box. Thank you. Thank you. Today, Richard, that will fly. Okay? For today, only for the day. We're going to move on to the next problem, guys. In that previous problem, just to recap, guys, we just had to multiply two monomials. In that case, you multiply all of the like bases together, aka multiply all the like variables together. And when you're doing that, you add those exponents on those terms. And we are so moving on to problem number 20, guys, as we are helping students in Algebra 1 prepare for their final exam. That's right, second semester, final exam, end of course. Anime Fab says, you're the best YouTuber. Thank you so much for your support, Anime Fab. Your comments mean a lot to me. Tony says, where did you buy this and your pen? I'm glad you asked, Tony. Look in the description box. You will see links to all of the tools that I use to produce the videos and other things I'm interested in. All right. So within the description box, Tony, check out the link for the Amazon affiliate store, and you'll get a direct link to those items that I'm using. All right. Anime Fab says U for university. There you go. Appreciate that, Anime Fab. That was cute. Let's go ahead and check out problem number 20, guys. So in this problem, it says, tell whether the slope of the line is positive, negative, 0, or undefined. So the first thing you should realize is that you're dealing with, guys, a vertical line. Oh, yes. And when you are dealing with a vertical line, guys, you have no slope. In other words, the slope is undefined. You can verify this by grabbing 2 points off of the graph and then solving for it. Okay, so for instance, if I choose the point, and this is all going, in fact, this equation, guys, is x equals to 4, just so you can reference that clearly. I don't know if you can see it on my screen, but the equation that we're dealing with is x equals to 4. If I were to grab 2 points off of this graph, let's go ahead and grab the x-intercept, and let's also grab this point right here. So if I were going to take the 2 points, 4, 0, as well as the point 4, 3, and I go ahead and label these as x1, y1, x2, y2, and then plug these into the slope formula, which is m equals y2 minus y1 divided by x2 minus x1. Plugging these values in, you'll have 3 minus 0 divided by 4 minus 4. Well, what do you end up with with this? You'll end up with 3 over 0. Can we have 0 in the denominator of a fraction, guys? Absolutely not. It's undefined. And so that's why you end up with the answer being no slope, aka undefined. And per this question, our choices were positive, negative, 0, or undefined. So the answer must be undefined. Richard says, if it was a horizontal line, would the slope be 0? Yes, it would, Richard. If it was a horizontal line, the answer would be the slope is 0. Good stuff. Just to make sure everybody's clear on this concept, guys, notice that if you don't know for certain, you can always grab 2 points from the line and use the slope formula in order to verify your results. And also, anytime you have a positive slope, that's when the line will rise from left to right. If you have a negative slope, the line will rise from right to left. And of course, a horizontal line has a slope of 0. And as you just found out, a vertical line has an undefined slope, aka it is no slope. It's undefined. Anime Fab says, will they tell you if it's going to be negative, positive, or undefined? You can solve for that, Anime Fab, depending on the situation. It depends on the problem. All right. So Tony says Noah's problem might be challenging. It may be too challenging for this class because it sounds like your problem that Noah has is a rational equation. And we don't dive too heavily into rational equations in Algebra 1, Tony. So that sounds like an Algebra 2 problem, which I'll be doing in a couple of weeks. Okay. So just keep that in mind, Noah and Tony, if that is what you need. All right, good stuff. So in problem number 21, and also Tony, you can have Noah watch our YouTube video called Rational Equations, and that'll help him out. There you go. All right. So problem number 21, it says to subtract. We have this expression that they want us to simplify, guys. And Anime Fab says that he or she understands now, which is awesome. Just trying to help. What you should notice is that in this problem, you have one quantity minus another quantity, guys. And when you're subtracting expressions like this, when you're subtracting polynomials, okay, that the first set of parentheses, as long as there's nothing on the outside of it, you can just drop those. So you can just rewrite this as 6a squared plus 3a. You don't even need the parentheses there. It's a waste of time. Appreciate that, Anime Fab. You are a he. Appreciate that clarification. But the second set of parentheses has a negative sign in front of it. That's a -1 distributing inside of the parentheses. So we can definitely show that we will get our arrows popping for this particular problem, guys. So multiplying each term within the second set of parentheses by -1, you need to change the signs of all the terms within. So we have the opposite of 4a squared, and we have the opposite of 2a after distributing the negative within the parentheses. Amen, amen. I'm glad you found that funny, Anime Fab. From here, we're going to be combining our like terms, guys. So I'm going to combine the a squared terms. I have 6a squared minus 4a squared. That gives me 2a squared, son. Then you can combine the a to the first power terms. We are not scared of this problem. We have 3a minus 2a. That gives me how many a's, guys? Exactly. 1a. That's it. That's the answer. The answer is 2a squared plus a. I'm putting a red box around my answer, Richard, just to let you know the red box is in effect. I'm red boxing it. I have to. Okay? Fabiola and I already know that we're here to protect our family at any given point. There you go. Anime Fab, on our previous answer, you do not want to write the 1 in front of the a because that would be redundant. The reason for that is that any coefficient in front of the variable is multiplying on that variable. So what is the end result of multiplying 1 times a? It would just be a, and that's why you don't need the 1. Anime says, how did you turn the positive into a negative? Because this negative in front of the second set of parentheses is equivalent to -1 multiplying on all those terms. A negative times a positive is a negative. A negative times a positive is a negative, Anime Fab. So that's using the multiplication rules for integers. That is what's going on. Fabiola is in the house. That's right. All right, so that's going to complete that problem there for problem number 21. Hopefully that helped, Anime Fab, and you said that it did. So I must be doing a decent job today. What's going on, Ashley Sharma? Thank you for joining us today, Ashley. I appreciate you. In problem number 22, it says to solve for x, guys. And you already clearly see that I'm about to get my arrows popping because they want me to do the distributive property. Tony says Noah is simplifying the square root of 88 over 472. Noah needs to simplify the 88 and 472 first, and it looks like both of those numbers are divisible by 8. So divide both of those numbers by 8 first. That should help him. All right, so we're going to go ahead and distribute here. We are distributing. We're getting those arrows popping. All right, and I'm going to show that I'll be distributing a -2 in that last set of parentheses, guys. That's right, Kaylee. Arrows popping. Exactly. So I'll be bringing down 4 times x, which is 4x, and 4 times 5 is 20. Then on the right side of the equal sign, we have 3 times x, which is going to be 3x, and then 3 times -2 is -6. Distributing the -2, and notice how I circled that negative to remind me that I'm distributing a negative value into the second set of parentheses here, into that last set of parentheses rather, or the second set of parentheses on the right side of the equal sign. We have -2 times x is -2x. We have -2 times 2, that gives us -4. And then after you distribute, we are going to combine our like terms. Ashley, I will be doing geometry next, and then after geometry, we'll be doing algebra 2. We're going in order of most high schools. So in 9th grade, generally they'll take algebra 1. Then as a sophomore, they'll take geometry. Then as a junior, they'll take algebra 2, Ashley. So we're going in that order. How you like that, Ashley? Huh? Or are you saying that you don't care about those people because you need algebra 2? All right. Ashley says, yes, thank you. No problem. So on the right side, we're going to have 3x minus 2x. That gives us x. And then combining the -6 and the -4 on the right side, we'll have -10. And I hate that 0, so we're going to fix it. That's a better 0. And done. Yeah. But we want to isolate the term with the variable. All right. Anime said, laughing out loud, he baited you out. Pretty much. So then we're going to subtract 8x to both sides there. Subtracting x to both sides, you have 4x minus x gives me 3x plus 20. On the right side, the x's cancel out. We bring down a -10, guys. Yes, we do. Yes, we do. Once we have that, I want to subtract 20 to both sides. Thank you. That's what I'm doing here, subtracting 20 to both sides. I have a smile on my face. I'm enjoying this process thoroughly. Thank you. I'll be then dividing both sides by 3. Oh, that's what I'm going to do. And I end up with x being equal to -10, which is the answer. Ashley is enjoying the chat. Ashley is enjoying the chat, guys. So we have -10. There we go. And Fabiola has her correct answer. Very good, Fabiola. In the house with your -10. And Fabiola says that she is red boxing it like a boss. That's right. Fabiola for president. We have problem number 23. Problem number 23 says, what is the value of x in the equation 3/4 x plus 2 equals 5/4 x minus 6? And the first thing I see in this problem, guys, is fractions. Yeah, I see fractions in this problem. And I prefer not to do the problem with fractions. So what I generally will do, guys, is multiply each and every term by the least common denominator, the LCD. is what I'm going to be multiplying each and every term by in order to kill the fractions. Tony says that Noah is red boxing it. Fabiola says we don't like the fractions, but that's all right, Fabiola. We know what to do with the fractions. We're going to get rid of them. That's right, Fabiola. Let's get rid of them by multiplying each and every term by the least common denominator, which is 4. That's exactly what we'll be doing, guys. So each term will be multiplied by 4, and then we'll just move on from there. That's what we'll do. Yeah. We're just going to multiply each and every term by that least common denominator to get rid of the fractions that we don't like. And so in simplifying our first term, guys, let's check this out. This 4 is technically over 1, and then you can simplify before you multiply. The 4's would cancel out to leave us with 3x plus 4 times 2, which is 8. Thank you. On the right side, the 4's will cancel out to leave us with 5x minus 4 times 6 is 24. So notice how multiplying each and every term allows us to eliminate all of the fractions in the equation. You can do this in any equation, guys. If you have fractions within it, you can multiply each and every term by the least common denominator and kill the fractions. Oh, yes. That's right. Kayla says, me too. I hate them. Exactly. Anime Fab. Yes. We're trying to be smart, Anime Fab. That's exactly what we're trying to do. Now, as I stated before, I prefer to have a positive coefficient in front of my variable. So I'll be subtracting 3x to both sides. See, I know a lot of y'all on that solve for the variable on the left-hand side train. But I ain't on that train. I'm on I need a positive coefficient train. I'm on that train. Okay? So, what did I do? I subtracted 3x to both sides of the equal sign using the addition property of equality, aka you can say it's a subtraction property of equality because I'm subtracting 3x to both sides. All is well. Then I want to isolate the term with my variable x by adding 24 to both sides of the equal sign. Yes, I do. I don't like that 4. We're going to make it better. It is better now. Thank you. You're a witness. You saw it. Go from sucky to better. Thank you. The left side of the equal sign, we have 8 plus 24 is 32, guys. On the right side, I'm bringing down my 2x. I'm canceling out those additive inverses. They're gone now. They had to go. I kicked them out the house. Bye. And now I'm going to be dividing both sides by 2. This is the division principle of equality. Thank you. My answer for problem number 23 is x equals 16. And I will put this in a red box. You better believe it. Oh, yes. Tony says, can you get this app on the computer? And what is it called? This app, Tony, is called Pen Ultimate. Pen Ultimate, and you can only get it on the iPad. There you go. Kayla, good job with that 16 for an answer. That's right. Good game. That's right. Good game. Fractions. Get rid of it. That's right. No, I was going to say that. That's right, Ashley. You can say it too. You can say it too, Ashley. That is our answer, guys, for problem number 23 up in this piece. We're moving on to the next problem. That's right. Problem number 24. What you going to do about problem number 24, guys? It says which of the following, well, let's just not say which of the following. Let's just say what is the equation of the line that has x-intercept equals to -2. And there you go, Ashley. Good job, girl. Good job. Which of the following, in other words, they want us to write the equation, guys. All right. Yeah. Let's fix these directions. We're going to fix the directions. That's right. The directions are jacked up. Let's make this proper with right. There we go. On the fly, hooking it up. Write the equation of the line that has x-intercept -2, y-intercept -4. Let's see about that. If we go ahead and write the x-intercept as an ordered pair, guys, that ordered pair would be -2, 0. If we write the y-intercept as an ordered pair, that point would be 0, -4. We can use these 2 points to create the equation of the line. That's right. And we will need to find the slope first. That's right. Kaylee, I see you over there. So the slope formula, guys, is m equals to y2 minus y1 divided by x2 minus x1. We're going to label first. Yeah. Go ahead and label those points as x1, y1, x2, y2. That's right, Ashley. Kaylee is cool because Kaylee passed the ASVAB and Kaylee gets her studying on with Fort Bend Tutoring, which makes her the coolest. Thank you very much. And now, that is, Tony, we're dealing with an iPad Air right now. Kindles suck and you should know that. Come on now. I thought you were a good viewer of Fort Bend Tutoring videos. There's no way I could do what I'm doing on a Kindle. Come on. Come on, Tony. Work with me. It's an iPad Air. Good job, Kaylee. Share the love. Share the love. So we have -4 minus 0 divided by 0 minus -2. Check out my skills on setting up the slope. There you go. What level grade math is this in the UK? I am not sure, Anime Fab, because I do not know all of the grade levels in the UK. But here in America, this is what most ninth graders in high school would take, which is going to be 3 years prior to them attending college. So you can go ahead and align that with the way things are set up there. All right. So, sorry I didn't know that off the top of my head, Anime Fab. But we're going to simplify this now, guys. And we have -4 minus 0 gives you -4. And then in the denominator, the opposite of -2 is +2. So our slope simplifies to -2. And we're going to put this in a purple circle. There you go. Anime Fab says you're in grade 7. Anime Fab, as I said at the beginning of this review, there are some 7th graders that take this information here in America. So this may be lined up just for you, depending on your school and how quickly you're learning your information, sir. Tony says, laughing out loud, you're smart and hilarious and intelligent. Tony, I'm doing what I can, sir. All right. I'm doing what I can. I'm just trying to share the love, Tony. All right. So, and I appreciate you coming by, Tony. All right. I know what you're up to, Dad, but I do appreciate you coming by, and I appreciate your consistency. All right. It will get you some free tutorials from Mr. Witt every once in a while, Tony. Every once in a while. So keep it up, sir. So you are going to now write your answer, guys, in slope-intercept form. We have the slope-intercept form, which is y equals mx plus b, right? And so let's go ahead and use these values that we've created to solve for the equation. We know that the m is -2, so that should be y equals -2x, and they gave us the y-intercept, guys. The b value is the y-intercept, and our y-intercept was given to us as -4. So therefore, we have our equation of the line as y equals -2x minus 4. Done and done. And Fabiola, you were correct. You are correct. That's right. No need for those question marks. That is the answer to the problem. That's problem number 24, guys. Good job. Great job. And as a reminder, guys, to please subscribe to Fort Bend Tutoring. Good stuff. Yes, you did get it. Kayla says done and done. Go ahead and share the stream with your people, guys. I would greatly appreciate that. Also, if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. There is a $sign at the bottom of the chat box there, at the bottom left. There you go. Ashley is dabbing on them. That's right, because she got the correct answer. Very good, Ashley, with that dab. And you can use that to do a super chat. Would greatly appreciate that. Also, there is a link in the description box for those of you that are not catching us live. You can use that PayPal link to make a donation to Fort Bend Tutoring so that we can bring you more free math tutorials. That is what's up. Let's move on to problem number 25, guys. Problem number 25 is coming your way. Here, they're asking us to simplify y to the 10th power times y to the 5th power. Anytime you're multiplying like bases, guys, all you have to do is add the exponents. That's it. That's all you got to do. So this becomes y to the 15th power. Oh, it's over. Yeah, I know you were expecting more, but that's the answer. Yeah, that it's over now. Thank you. Yeah, I'm gonna move on to problem number 26 now because it's over. Thank you. Had a red box around that. Sure did. Yes, I did. Anime Fab says that was easy. We want every problem to be easy, Anime Fab. And it's easy when you know what you're doing. You know? That's the only difference, Anime Fab, between the easy and the hard problems is you knowing how to do it. That's the difference. So that's what I'm here to show you. I'm here to show you the step-by-step process to solve the problems that you encounter, especially on your algebra final exam. Oh, yeah. We have problem number 26, guys. It says to find the slope of the line that contains the points 1, -1, and -2, 8. Oh, yeah. Yeah. That's right. That's right, Anime Fab. I am the boss man. And I am a G. Very good, sir. Let's move on by labeling these points. We got X1, Y1. I know that Kaylee is with me on this. All right. So we got X1, Y1. We got X2, Y2. I know Fabiola is down with a slope formula. We got Y2 minus Y1 divided by X2 minus X1. I know Richard is down. All right. I know Noah is down. I know Tony is down with the slope formula. Absolutely. That's right. We're going to be plugging in these values now. And plugging in the values, we have 8 minus -1 divided by -2 minus 1. Notice how I set it up, guys. Notice how no matter what, I'm including the minus signs that are in the formula. So whether or not the value is positive or negative for my X1, Y1, X2, Y2 values, I don't care. I still need to include the minus signs from the formula for the slope. Therefore, when I'm plugging in Y2, that's a value of 8, right? But then the formula says to write down the minus sign, so I do. And then the value of Y1 happens to be negative, and that's why I put it inside of parentheses. That's right. Absolutely. Kaylee getting the compliments again. That's what's up. Real, recognize real. Good stuff, Ashley, for not being a hater. Good job, girl. That's right. Good job at not being a hater and sharing the love. Good stuff. Let's continue on with this problem, guys. That's right, as we are visiting the social experiment called Kaylee. So we have 8 plus 1 divided by the -2 minus 1, and then we're going to simplify this. We have 9 divided by -3. And in simplifying 9 divided by -3, we'll end up with -3 for our slope, ladies and gentlemen. And that is the answer to that. That's right. Anime Fab, the slope is called the gradient. Yes, and most of the time when they are referring to the gradient, they want you to change that slope into a percentage. There you go. Mike Fisher says that he loves it. Thank you so much, Mike, for your support. Appreciate that. Problem number 26, guys, is in a can. There you go. Anime Fab, I think I have an example of converting the slope into a gradient when you are looking at finding the slope video for Fort Bend Tutoring. I believe it's one of the last problems that I show you how to write the slope as a gradient, or how to find the gradient, okay? Because most of the time when they refer to the gradient, as far as the slope is concerned, they're looking for a percentage. They want you to rewrite it as a percentage. Amen. Let's, guys, move on to our next problem. That's right. Anime Fab says, thank you. It is my pleasure, Anime Fab, to share the love, man, just like Mike is doing. We have in problem number 27, guys, we say that 5 times the difference of a number and 3 is 25. Solve for the number. So here we want to translate this into an algebraic equation. Let's do just that. So 5 times the difference of a number and 3. We're going to have this written as 5 times the quantity of a number that we don't know. So we'll call it x minus 3. And this is equal to 25. So because they said we were dealing with the difference, that means that we were going to subtract here, guys, right? And we had 5 times that difference, which is why we wanted to put the 5 on the outside of the set of parentheses here. So Kaylee, we want to rewrite that using parentheses because they want 5 times the difference. So anytime they say 5 times a sum, or 5 times a difference, that difference or sum will be included within the parentheses there. That's all right, Kaylee. We are here to learn. So even though you've already made that achievement of passing your ASVAB, we want you to be be even sharper when it comes to your math. Ashley says, haters are bad. They can leave. Go math. Absolutely. Absolutely, Ashley. Absolutely. And Ashley, just because of that kind comment there, Ashley, and because you are not a hater, we're going to go ahead and make you a moderator. All right. So there you go. Ashley is in the house for good, guys, as a moderator. Good job, Kaylee. So now we're going to solve for x by doing one of the following. We could either distribute, which I love, which means I can get my arrows popping, but I can also, guys, divide both sides by 5. Let me show you that. See, by dividing both sides by 5, the 5s will cancel out. I can bring down x minus 3, which equals to 25 divided by 5, which is 5. So what I mean is I'm able to simplify that. Moderators, Ashley, are able to post links, and they're able to kick out people that are being haters. Angry Hermit is in the house. What's going on, Angry Hermit? I was hoping that you could join us today. Thank you so much for joining in. And of course, everybody is showing Angry Hermit love because Angry Hermit is the stuff. Way to go, Angry Hermit. That's right. Angry Hermit says, sorry I'm late. I was at the park. There was a dog and a person, and I'm shaking now. All right. That's right. I understand, Angry Hermit. Not used to being around those people. Good deal. So here, guys, we started out by simplifying the entire equation that we set up by 5. All right. Anime Fab already recognizes that G, Angry Hermit. That's right. And then solving for x, we'll be adding 3 to both sides of the equal sign here, guys, using the addition property of equality, and x equals 8. And this is our answer in a red box. There it is. So we just solved for that number, guys. We did. Mike Fisher says, this review has helped so much. Got my love for math back. Thanks, Prof. Hey, my pleasure, Mike Fisher. My pleasure. In fact, guys, we're going to just to let you guys know, I'll be live again this Saturday with part 2 of this final exam review. So even though we have hit you up with so many problems thus far today, we will have more problems on Saturday as I hit you up with more problems for this final exam review. That's right. I want to get you guys as prepared as possible because I want you guys to pass math. Angry Hermit says, you make math amazing, Mr. Witt. No, it's only because of you, Angry Hermit, and all of my peeps that come spend time with me when we're trying to help the people. That's right. Fabiola says, yes, more practice is always better. Absolutely, guys. Absolutely. Let's go ahead and practice together. By me doing these problems with you guys, I'm improving my skills as well. That's right. The more, the merrier. Good stuff. And I get to kick it with you guys. How good is that? I mean, it's not often I get to chill out with Angry Hermit and Mike Fisher and Fabiola and Anime Fab and Kaylee and all of you guys. I appreciate you guys. You know what I'm saying? One big family. Here we have problem number 28. It says that the length of a rectangle is twice the width. The perimeter is 36 centimeters. What is the length? Guys, we're referring to a geometric object, all right? We're referring to a rectangle. So let's go ahead and show it. There we go. Let's go ahead and draw ourselves a rectangle that we can refer to. So now that we have that, we know that the length of the rectangle is twice the width. So we don't know what the width is, but we do know that the length is twice that amount. So we're going to say that our length is equivalent to 2 times the width. All right. So let's go ahead and fix that W because it was kind of ugly. It's still kind of ugly, but you guys know what I mean, right? And we know that the perimeter of this rectangle is 36 centimeters. Angry Hermit says, question, do you find that practice makes it so you don't make as many simple mistakes? Absolutely, I do agree with that because I do that a lot, and I was wondering if I need more practice. There's 2 things that you can do, Angry Hermit, to make sure that you're not, well, actually 3 things that you can do to make sure that you're reducing your simple mistakes. One is show all the steps. Do not skip any steps. That's the first thing I'm suggesting. Number 2, slow down. You may be doing the problem way too fast. Okay? So don't skip steps. 2, slow down the process. Don't try to rush through the problem. Okay? Number 3, you want to do a lot of the problems to get the practice under your belt after you understand the steps that it takes to solve the problem. And then the last thing you want to do is you want to master the concept. You know that you have the concept mastered when you can show someone else how to do it. Okay, so if you do those things, then you will reduce your simple mistakes, you will become more accurate, and you'll be able to help someone else that may need assistance. That'll be even better. And when you're showing someone else how to do this, Angry Hermit, it makes you understand the problem that much more. All right. So great question, Angry Hermit. Good luck to you. All right. So the next thing we need to know, guys, is what is the perimeter of a rectangle? The perimeter equals to 2 times the length plus 2 times the width. And we're going to set up an equation based on that. Good stuff. So that means that we know that the perimeter is 36, right? And it's going to be 2 times our length, which is 2w, plus 2w. Okay? So we have just substituted all our given information into the equation for the perimeter of a rectangle. All right. So now that we have this, and it looks like Fabiola has her equation set up perfectly. Good job, Fabiola. We can now solve for the width by solving this equation. The Noble Nashi says, just tuned in. I'm glad you're live. Let's do some math. Absolutely, Noble Nashi. Go ahead and read this word problem, set up your equation, and we're going to solve for the length. All right. So just keep in mind that even though our current equation is set up to solve for the width, they want the length as the result. All right. So we haven't answered this question, guys, until you give them the result of the length of the rectangle. All right. So let's go ahead and continue. All right. So now, solving for our equation that we have set up, we'll have 2 times 2w. We'll end up with 36 equals to 4w plus 2w. So 36 equals to 6w. And then dividing both sides by 6, guys, you'll end up with your width being equal to 6. All right. So dividing on the left side, we have 36 divided by 6. So the width is 6 centimeters. However, recall that our length is equivalent to 2 times the width, twice the width, right? So to solve for the length, you're going to be multiplying 2 times 6, and that gives you a length of 12 centimeters. And this is our answer right here, 12 centimeters for the length of the rectangle. Ashley says, I got to go, guys. Thank you so much. This was an honor to be here. Thank you for making me a moderator. God bless you and your math skills. I appreciate it so much. I'll be tuning in again on Saturday or Sunday. Bye, Ashley. Thanks for coming also. So good stuff, Ashley. Thank you so much. Let's go ahead and give your post a little love here so people can see what's up. And Anime Fab is correct with 12 centimeters. Good stuff. Very good. We red boxed it. Ashley says, it was nice to meet you all. Love math always. I just subscribed. Thank you so much, Ashley, for subscribing. Thank you so much. Good deal, guys. Let's continue on. Let's continue on to our next problem. We have problem number 29, guys. Problem number 29. They're asking us to multiply the quantity a plus b times the quantity a minus b. That's right. And if you're familiar with this format, guys, you should know that the end result of this will be a difference of squares. The end result of this will be a difference of squares. Let's go ahead and multiply this out. And you guys already know I'm about to get my arrows popping here. Okay. And if you guys want to help out Forbidden Tutoring as well as get some cool swag stuff, you know what I'm saying? Go ahead and check out our t-shirt shop. The link is in the description box where you can get your arrows popping t-shirt. Absolutely. All right. Good stuff. Kayla says, I love those. All right. Well, let's get these arrows popping in, Kayla. So I got my arrows popping here, guys. And we have a times a, that gives us a squared. We have a times negative b, that gives me negative ab. We have b times a, that gives you a positive ab. And finally, multiplying b times negative b gives you negative b squared, guys. And what happens to those middle terms? What happens to the middle terms? Sarah Penguin already knows. The middle terms will cancel out, and your end result will be a squared minus b squared. And you better believe we will be red boxing it, guys, as our answer is a squared minus b squared. Sir Penguin in the house with the correct answer. That's right, Fabiola. The middle terms eliminate one another because we have additive inverses. So notice that I made sure that I always wrote my terms in alphabetical order. That way it was easier for me to identify the like terms that I could cancel out in the end, or combine for that matter. So it turns out that I had a negative 1ab, a positive 1ab for my middle terms, and those cancel out. Yeah, they go away. They add to 0, in other words, Fabiola. So great question. A great statement, by the way. All right, you may not have been asking a question. You may have just been stating the facts, and that is that they eliminate themselves. That's right. Done and done with problem number 29, guys. That's what's up. All right. So, Major League Gaming with the math, huh, Anime Fab? I'm trying to do my best here. All right. Appreciate that compliment. Sir Penguin says, can't forget all the factoring tutorials I watched of yours. Oh, do not forget those, Sir Penguin. Believe it or not, Sir Penguin, of all of the videos that I create, I personally enjoy the factoring ones the most. I love factoring. I really do, Sir Penguin. So if those videos were able to help you out, that makes me that much more excited about it. All right. It makes me want to do some more, which I need to do. All right. Thanks for that feedback. That is important to me. Guys, just to let you know that this will be our last problem of the video. All right. And that's going to be problem number 30. And reminder that I will be live again on Saturday with part 2 of our final exam review for Algebra 1. Remember, Algebra 1 is a course that many students take. All right. For example, here in America, there are some 7th graders that take this course, 8th graders, 9th graders, and some 10th graders, as well as many adults that are returning to college, returning to school, and they've been out of the classroom for a long time. They need a refresher over this information. So either they get their refresher on their own, or they're placed into developmental math classes in college where they have to refresh their memory on what they learned at a younger age. So this Algebra 1 review helps a lot of people. So I couldn't wait to get this up and available for you guys. Angry Hermit says, thanks for the stream, Mr. Witt. Anime Fab says, true. And it's all good. What time will I be live on Saturday? Right now, it is about 4:42 p.m. and I'll be live on Saturday at 10 a.m. just to give you a frame of reference. Also, Kaylee, if you will click that bell notification next to the subscribe button, you will be notified when we're live if you haven't done that already. So by clicking that bell icon, guys, next to the subscribe button, you will be notified when we're live and when we're posting new content on Fort Bend Tutoring's YouTube channel. Good stuff. My pleasure, Kaylee. No problem. Let's go ahead and knock out problem number 30, guys, and then we'll chat a little bit, and then we'll call it a day, all right? So it says, if you graph y equals x squared minus 6x plus 9, the y-intercept of the graph of the equation is, and this is a great question, guys, a different question that we haven't seen today. And what you should know is that anytime you're giving a function, all right, and you're asked for the y-intercept, you should know that you can always solve for the y-intercept by replacing the x value with 0 and then solving for y. So this is exactly what it looks like. Sir Penguin, you are correct. You'll have y equals 0 squared minus 6 times 0 plus 9. So once again, the process, good job, Angry Hermit. So once again, the process for solving for the y-intercept of any graph is to replace all the x values with 0 and then solve for y. So what happens here, guys, is we end up with 0 minus 0 plus 9, right? And this gives us y equals 2. This is just 0, doesn't do anything, right, guys? So the answer is just 9, okay? So there you go. So that's right, Angry Hermit. Angry Hermit says it's kind of obvious if you know the formula. That's correct. If you are already aware of many of these formulas, of many of these concepts in math, that's when it changes from being difficult to easy. And that's why we go through all these different step-by-step processes, guys, all of these different types of problems so that you can become more comfortable with the process and everything will become easier to you. That's the whole goal. So you can write your y-intercept as 9, and sometimes, guys, they'll prefer you to write the y-intercept as an ordered pair. So as an ordered pair, you would write it as 0, 9. Okay. So what they want you to know is, okay, I see some questions. Anime Fab says, what's the formula? Well, it's more of a process, and Angry Hermit was referring to the slope-intercept form, but Angry Hermit, this does not apply in this problem. The reason why the slope-intercept form of a linear equation doesn't apply in this formula, Angry Hermit, is because this is a quadratic equation. It's not in that form. It's our variable is raised to the second power, so that would not be the formula that we would be referring to. Okay, so in fact, you could say that the formula for this is one of several. For a quadratic equation, you can use the formula y equals ax squared plus bx plus c. That would be the standard form of a quadratic equation. You can also use this form, which is called the vertex form of a quadratic equation. All right, so this would be another one that you can use as far as a quadratic equation is concerned. But not to be bogged down with formulas, Anime Fab, what you need to know as far as finding the y-intercept is that all you have to do is replace all the x's with zeros and then simplify. That's the easiest way to remember, especially for your test as far as the y-intercept is concerned for any formula. So therefore, you don't have to memorize all the different equations that are out there, like remembering all the forms of a linear equation, remembering all the forms of a quadratic equation. What you need to know is if they're asking you for the y-intercept, plug in 0 for x and simplify. Done. Easiest way to remember. Okay, and no problem, Angry Hermit. We're all learning. Okay, so I made a mistake earlier in the stream that I had to correct. All right, so I'm not perfect. We're here to learn, and we're learning together, guys. All right. So does it work for all of them? Yes, Anime Fab. It works for every problem that they're asking you for the y-intercept. You plug in 0 for y and solve for x. Absolutely. All right, guys, so what you need to know is that I want you guys to do me a favor and subscribe to Ben Tutoring if you haven't done so already. Go ahead and click on that bell icon in order to get a notification of when we're going live. If you're able, please donate to YouTube to our YouTube channel Ben Tutoring. You can find a link for the donation in the description box, and visit our t-shirt shop as well as our online store and our Amazon store, okay? Because we want to spread the love. Angry Hermit says, I'll be the first to admit that I am totally ignorant when it comes to math, but that's why I'm here. Good job, Angry Hermit. Let's go ahead and learn some stuff together. Sir Penguin says, thank you for the stream. All right, I'm from the UK, and if all streams start the same time as this one, they work out so perfectly. Hopefully you'll see me the next time. Absolutely. Dalsim, all right, in the house. What's going on, Dalsim? Good to see you again. Positive videos and algebra. Absolutely, guys. So we are going to be heading out of here. Thanks to all of our moderators that we had in our channel today, in our stream today. Thanks to Angry Hermit. Thanks to Kaylee. Thanks to Fabiola for always coming through and chiming in. Go ahead. You know what, Fabiola? Let me go ahead and make you a moderator as well, Fabiola. Why not? There you go. Fabiola is in the house. Excellent. I'll try to read you live on Saturday. I'll be working, but hope to tune in. No problem. Angry Hermit says, thanks again, Mr. Witt. Bye, everyone. Thank you guys so much, and I appreciate you chiming in. And remember, I'll be giving you part 2 of this review on Saturday. Peace. Take care, guys.
Thanks for watching. We appreciate you hanging out with Ben Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.